Hi, and welcome to your Bare Basics lesson for today, where I'm going to introduce you to a new concept called the radian. Whenever you've done work before that has involved angles and also using sine and cosine in any of your trigonometry, we have used degrees when we're talking about angles. When we talk about periodic functions, such as your sine curve and your cosine curve, we use a measure called radians. And in this video, we're going to look at what a radian is and how you convert between degrees and radians. It's important to note that your calculator has a radians mode. So when you actually do any calculations that involve periodic functions and you see that the measurement is given to you in terms of radians, you need to change your calculator to radians mode. I'm not going to go through that with you now because everyone has different models of calculator, but we'll certainly look at that in class. All right, so let's actually move on to what a radian is. And I'm going to take you back to first principles with this, and we're going to have a look at constructing a circle and what a radian is in terms of a circle. Okay, so what I'm going to do is I'm going to construct a circle. So I've got my compass and I'm going to scribe my circle. Here we go. There you go. So I've got a circle there and you can see where my centre is. And I'm going to draw a radius which goes from the centre of my circle out to the circumference. Then what I'm going to do is I'm going to scribe an arc. So I'm putting my tip of my compass on where my radius meets my circumference. And I've just scribed an arc there, and by joining those lines there, oops, there we go. So what I have here now, when that comes into focus for you, is this distance here is 1 radian. So 1 radian is equal to the angle that is formed when a arc, the length of the radius, is actually scribed. Now, this equals 60 degrees. 1 radian is 60 degrees, and I can prove that in 2 ways. The first and the most simple way is to join the dots there, and I now have an equilateral triangle which has a side length of whatever my radius is. So we know that in an equilateral triangle, the angle, each angle is equal, so that must be 60 degrees because we have 180 degrees in a triangle. But to be a little more robust than that, we can prove it mathematically as well. Now, I can continue scribing arcs around my circle. So from this point, that was 1. We have 2, 3, 4, 5, and to get it back, we've got 6. So I know that 6 times the radius will give me the circumference of my circle, which is found using the formula 2 pi r. So that is 2 times pi times the radius. So it doesn't matter what my radius is. If I divide through by the radius, I can cancel the radius from both sides. So I get 6 radians must be equal to 2 pi. If I divide again, so I can say 6 radians. So 1 radian, using my basic algebra, if I divide both sides by 6, 1 radian will give me 2 pi on 6, which when cancelled is pi on 3. So 1 radian must be pi on 3. Well, we know that's 60 degrees. But how can I be sure? Well, we know once again that 6 radians will take us around the whole circle. So 6 radians, I'll say that's 1. So 6 radians must also equal 360 degrees. Therefore, 1 radian is equal to 360 on 6, which is equal to 60 degrees. And we'll call that 2. So I can therefore say that pi on 3 is equal to 60 degrees, and therefore pi will equal 60 degrees times 3, which is 180 degrees. Okay, that's a little bit confusing. I understand that. You need to know that 1 radian is equal to 60 degrees, and expressed in terms of radians, we use pi. So pi on 3 is equal to 60 degrees. 180 degrees is equal to pi. That's how we know whether we're dealing with degrees or radians. Radians will have a pi in them in there when it's written out. So now we have to look at converting between degrees and radians. We've just worked out that pi is equal to 180 degrees, and this is the focal point when we actually need to convert degrees to radians or vice versa. So let's have a look. First of all, let's go from degrees to radians. We need to multiply the angle in degrees by pi on 180, because if pi is equal to 180 degrees, then 1 degree is going to be pi divided by 180. So if we have 30 degrees, we multiply 30 by pi on 180. The common factor between 30 and 180 is 30, so that becomes pi on 6. So 30 degrees is equal to pi on 6 radians. Once again, because we've got the pi in our expression, we know that that is referring to radians. It's just as simple going back the other way from radians to degrees. So once again, start with the fact we have pi is equal to 180 degrees. This time we want 1 radian, so we divide by pi and we get 180 divided by pi will allow us to convert back to degrees. So we're multiplying the angle in radians by 180 divided by pi. Now, just before I go on and do the example there, let me just reinforce to you. When we're converting from degrees to radians, we want pi in our answer. Therefore, pi is going to be in the numerator. When we're going from radians to degrees, we want to get rid of the pi in our expression. So we're going to divide by pi. We're using the multiplicative inverse here. That's the principle there. So it cancels out the pi's and we're left with just a number, which is our degrees. So if we have 3 pi on 2 radians, and we're converting that to degrees, we're multiplying 3 pi on 2 by 180 on pi. The pi's cancel straight away, so we get rid of them, and then we can cancel between the 2 and the 180 degrees. So 2 into 180 is 90, and we're left with 3 times 90, which is 270 degrees. So converting between the two is quite simple, and it's just a practice thing, and we'll do lots of that. Now, the last thing that we need to think about is renaming our unit circle for radians. So our unit circle that you've come to know and love has our circle situated on the centre of the Cartesian plane, and our coordinate points 1, 0, 0, 1, negative 1, 0, and 0, negative 1. What we can do now is we can convert. So remember, I said that our circle always starts at the point 1, 0. That is our 0 degrees, and you'll be pleased to know that it's also 0 degrees from radians. So as we move up to through our first quadrant, up to our 90-degree mark, we can then rename. So instead of 0, 1, well, it's still a point 0, 1, but instead of 90 degrees, we say that it is pi on 2. And then as we move through, we can say it is pi and so on. And so here we go. We've got our circle in terms of our what we've got with our radians, and I can see that I've just cropped out the bottom part, which I didn't mean to. So at 270 degrees, or at the bottom of our circle, that is actually negative pi on 2. This has been your Introduction to Radians lesson. If there are any questions, just ask me in class or email me. I understand that it's a new concept for you. I hope this video has helped explain it a little bit, at least what a radian is and how to convert. Remember, the idea of bare basics is to explain things and make maths just that little bit more bearable for you.